Okay, so in the last class, we looked at trigonometry. Um, Sorry, in this class, we'll be looking at trigonometry, which is something that is new to all of you, and that is what I was referring to towards the end of the last class when I told you that there'll be a small surprise in this class. In the last class, we talked about simple interest and compound interest, which I think all of you must have enjoyed, I hope. So I wanted to give you a little bit of an introduction to what trigonometry is all about. How many of you have heard of the word trigonometry ever in your life? Okay. And let's before I start this topic, let me give you a few disclaimers. This is something that is usually introduced at the beginning of your 10th grade, uh, and it is something to do with triangles, and it is something that will take up most of your 11th grade and 12th grade mathematics. And the good thing is that it is not as difficult as the word looks like. It's extremely simple. I was first introduced to it when I was in 8th grade. Actually, not. I think I was first introduced to it when I was in 6th grade by my father, but I got a little bit more clarity of it when I was in 8th and 9th grade, so when I was your age, and I did not find it that difficult. In fact, I found it interesting, and I was wondering why they don't teach it before 10th grade. So, sorry, just a second. Yeah. Uh, I don't want any of you to feel that this is something hard because I told you that it's 10th grade stuff. It's not really that hard. I just told it to you so that you will know when to expect it in your school curriculum. So, okay, let's forget all of that. Let us first try to understand what happens in a right angled triangle. So, all of you know about a right angled triangle, right? So, can you all see this mouse pointer on the screen? Okay, so a right angle triangle, I'm not able to draw here, so I will just try to, show you. It will be something like this. Okay, you know that very well. So in fact, I'm actually trying to I'm looking for a software where I can actually draw at the same time when I'm typing, but I've not yet encountered any topic where I need to draw. So let's try to manage with this. So you all know right angle triangles, and you kind of see them all over the world. We'll try to understand what happens in a right angle triangle first before we get into trigonometry as such. So in a triangle, let's just quickly list down some of the things that we know about a triangle. There are three sides. Okay, this is very simple to understand. One angle is 90 degrees. Sum of all the angles is 180 degrees. Okay. Um, do you know of this property in a triangle that the side opposite to the largest angle is the largest side, and the side opposite to the smallest angle is the smallest side? Did you know of this property of triangles? Have you heard of this before? You can try to draw any shape, and you'll always notice that if the angle is small, the side opposite to that is also going to be small, and if the angle is large, the side opposite to that is also going to be large. It's kind of you can also think of it intuitively, because a larger angle means that those two lines will be going further and further away from each other as they go apart, because the angle is larger, right? They just keep getting further and further away. So a side drawn to connect them will be a very large side. But if it's a small angle, then they still are somewhat near to each other, even if they go farther away. Sorry, somebody had muted my microphone. Am I audible now? Okay. So what I was saying was, in a right angle triangle, the largest angle is going to be 90 degrees. And in any triangle, you cannot, sorry, not in any triangle, in a right angle triangle, in any right angle triangle, you cannot have an angle that is more than 90 degrees. Can somebody tell me why? You cannot see. What do you mean you cannot see? Okay. Tanvi Gujarati, can you turn on your microphone and tell me why the largest angle in a right angle is always going to be 90 degrees? Hello?
Hello.
Yes.
Yeah, so one of the angles is always 90 degrees,
Mm-hmm.
and the sum of all angles in a triangle is 180 degrees.
Very good.
So so
So
you
what?
cannot and since if one if for the opposite angles, if
Mm-hmm.
one angle is small, then the other angle is also small, and that way.
Mm-hmm.
So
Okay. Okay.
if one of the angles is big, suppose if one of the angle becomes 102, no, it can't be 102 because
Why can't it?
180 minus 90, you have 90 degrees left, and so the other two angles can only be a sum of 90 degree. You can't have more.
Very good. Very good. Okay. So I hope all of you understood what she said. Because the sum has to be 180 degrees, and because already there is one angle that is 90, you cannot have another angle that is more than 90 degrees. Okay? You cannot have another angle that is more than 90 degrees. It's just not possible. But do not think that in a triangle 90 degrees is the largest. You can have a triangle where an angle is 120 degrees. The other two angles could be 30 degrees and 30 degrees. One angle could be 120 degrees. But that is not going to be a right angle triangle. We are only focusing on right angle triangles. So there has to be one right angle, 190-degree angle. Therefore, that has to be the largest angle of that particular triangle. Okay, now if we apply this rule, then we realize that the angle which is opposite to the right angle will always be the largest angle. Sorry, the largest side of the right angle triangle, because we know that the side which is opposite to the largest angle will be the largest side, and the side which is opposite to the smallest angle will be the smallest side. So if the largest angle is 90 degrees, the largest side has to be the one that is opposite to the right angle, and we call that side as the hypotenuse. Okay, so the hypotenuse is the largest side in a right angled triangle. When I say largest side, I mean the longest side, so it's just the same thing. Okay, so these are just some of the basics of right angle triangles, and I hope you guys understood. Now, let's talk about something really simple. Um, let's say that I have 6 different friends of mine. Okay, let's say I have 6 different friends of mine, and I will call them uh, let's give some cricketer names. I'll say I have AB, Stain, Amla, Callis, Cook, and let's say Tendulkar. Okay. Suppose I have this six people and I have two seats. I have one seat A and another seat B. Okay. This AB is different from this AB. This is the name of, let me call it De Villiers. Okay, we have two seats. Can you tell me in how many different ways I can, sorry. Let's say that I have only three people, okay? I don't have six people, my bad. We have three people. We have De Villiers, we have Stein, we have Amla, and we have two seats. Can you tell me the different ways in which I can make these three people sit in these two seats? There's a car and there are two seats, seat A, seat B. There are three people. How many ways can we make them sit together? One way, can you just list them? I want you to list them and then tell me what are the different ways in which we could write it. Just try to list them on paper or wherever and then try to count it. And once you're done counting, tell me how many numbers, how many ways you got. Okay, Aryan feels 3. I want somebody else to. Okay, Lavnish says 3. Okay. Who else has any? Does anybody else have any answer to that one? Remember that the order matters. So if AB de Villiers is sitting here or here, that's different. It's not the same thing. So a person sitting A and a person sitting B, it's different. Tanvi says more than 3. Very good. So how many do you feel, Tanvi? Okay, you can take your time and list. Okay, Tanmay says 6. Okay, that's good. Does anybody else feel that it is 6? So I'll just write down. We can have De Villiers here, and we can have Stein here. We can have De Villiers here and Amla here. Then we can have Stein here and we can have Amla here. Okay. So these are the first 3 things that you can get. Now what you can do is just reverse the order of everything. So you get Stein, De Villiers, Amla, De Villiers, and then you get Amla, Stein. Okay. So with 3 people, to make them sit in 2 different chairs or 2 different seats, we had 6 different ways of doing it. Okay. So now that you know that for 3 there are 6 different ways, let's try to do it for a triangle. A triangle has 3 sides. No, you cannot repeat one pair. The pair, each particular situation has to be unique. So if you have one situation in which De Villiers is sitting in the driver's seat and Stein is sitting in the passenger seat, then you can have Stein and the driver and De Villiers in the passenger. That is different, but you cannot repeat it. If you repeat it, then that's not going to be unique. So there are 6 different ways. So now a triangle has 3 sides. Okay. We want to study how those 3 sides are related to each other. We want to study the ratios of the sides to each other, with each other. Okay. So what we're trying to do is we want to know, different ratios of side A to side B. We want side B to side C and all of that. So now a ratio is, let's say, one term to another term. So you can have two things in a ratio, right? One is to the other. So you can compare two things in a ratio. Let's say we are only comparing two things, and the triangle has three sides, A, B, C. You all know that ratios and fractions are very similar to each other. So instead of ratios, I can even say fractions. So if I want to study the ratio between side A and side B, I can say A by B. Okay. So in that way, if we see how many different fractions can you create out of these three sides, it's the same thing. Think that the numerator and denominator are like the seats on that car, and these are the three people. So one is A by B, one is B by C, one is A by C, and now we can just interchange the orders. We have B by A. What else? C, C by B, and we have C by A. Okay, so we have these 6 different ways in which we can look at the sides of a triangle. So what we will do now is, let me go to Google and we will look at one triangle image. Okay, we'll look at one triangle image. So let's see a triangle where they have named A, B, and C. Okay, so there is one triangle, and let me pick a better one. Okay, so there is a triangle here. You can all see this triangle, right? Can you all see this triangle clearly? Okay, so now we have A, we have B, we have C, we have three different sides. Do not get confused with this capital A, capital B, capital C, because these are the angles. Okay, we are only looking at the sides. So then we can say A by B is one ratio, A by C is another ratio, B by C is another ratio, and then there is C by A, there is C by B, there's A by B, there's B by A. So there's 6 different ways of labeling a particular triangle. Okay, so let's go back to our document. So there are 6 different ways. Actually, here I've given them capital letter names, but usually when we talk about triangles, the sides are labeled in small letters and the angles are labeled in capital letters. Okay, that's the convention to follow, but here I just wanted to make it quite looking prominent. That is why I've labeled it as capital letters. Okay, here comes the first big confusion. When we are talking about right angle triangles, okay, we know that we're talking about right angle triangles, and you also know that we are trying to create ratios out of them. Here comes the question: which side is side A? Which side is side B? And which side is side C? In this particular triangle, we have A, B, and C as this side, that side, and that side. But in this particular triangle, this is A, this is B, this is C. In this particular triangle, this is A, this is B, this is C. You could have so many different triangles, and you can have different ways of labeling A, B, and C. So there is a little bit of confusion. You don't know which side you're talking about. Somebody tells you that I have a triangle in which the ratio of the side A to side B is 1:2. Okay, they say that. Can you draw the triangle? No. Which is A, which is B? Three people might draw three different triangles. Somebody might have this as A, somebody might have this as A, somebody might have this as A, and it all gets very complicated. So how do we generalize instead of just giving names like A, B, and C? Can we generalize? Can we generalize? Can you somehow think of a strategy in which we are able to solve this confusion? Can you all see this picture here? Can you see this picture? Is this picture visible? Okay, this picture is visible. Hello? Can somebody tell me if this picture is visible? Okay, sorry.
Sir, visible.
Okay, thank you. So do not get confused by this picture. Just try to look at this picture and try to think what this picture is stating. So first of all, this is a right angle triangle. That's what you know. Let me try if we can copy this picture and paste it here. Will that work? Okay, very good. Okay, now there's no more problems. So what is happening here is this is one angle. Okay, this is some angle. We don't know what that angle is, but this is some angle. The way by which we can stop all the confusion about side A, side B, and side C is by giving them certain names that will make us very clear about where they are positioned in the triangle. So if this is our angle, think this is your angle. Okay, let's say we're standing over here. You're standing at that particular angle. First of all, you do know that this side is the hypotenuse. Can somebody tell me why this side is the hypotenuse? Because it is the longest side in the triangle. Remember, we first realized here that the hypotenuse is the largest side in a right angle triangle. So whenever we say hypotenuse, there is no confusion. You know which side you're talking about. It has to be the longest side in the triangle. Okay, the longest side is hypotenuse. So this one side you know. Now this side you will call it as an opposite side because it is opposite to where you're standing. You are standing here at A, and this side it is opposite to you. So instead of calling it A, B, or C, you'll call it the opposite side. It's exactly opposite to you. This is the hypotenuse. You know that this is the hypotenuse. So there is this one side which is remaining, and you will call it adjacent. Do you know what is the meaning of adjacent in English? Adjacent means close by, right next to. So in the class you say that this person is sitting adjacent to me, he's sitting next to me. So instead of giving them names like A, B, and C, which can be confusing, you give them names based on where they are located in the triangle. So you pick one angle, okay, you decide which angle that has to be, and you say that from that particular angle, one side has to be adjacent to that angle, one side has to be opposite to that angle, and the hypotenuse, you anyways know where it is. It's like if you're batting here, you know that which is the leg side, which is the offside, you know where the umpire should be standing, where is the side screen. So there is sense of direction. If I just told you that, okay, on the ground there is the side screen present, can you guess where it is present? It is present straight. What do you mean by straight? It could be straight to the commentary box, it could be straight to the people in the ground, it could be straight to the umpire, it could be straight to the batsman. You don't know where it is. Then you say the pitch is present, you know, in the center of the ground, and then you say that the batting happens on one side of the pitch, and then you say that the side screen is present at a line which is exactly perpendicular to the radius, or you know, make such statements like that. You say a line which is straight from where you're standing as a batsman, you see exactly in front of you, and then you say you tilt up 60 degrees, you'll see the commentary box, and then you say right angle to the side screen is the offside, and another right angle on the left side of the batsman is the leg side. So you can kind of make these directional senses, you know, direct terms based on direction of the place and the object, that gives you a better sense of where they are, rather than just giving them A, B, and C, and you know, ambiguous terms like straight line or curved line, or it is present that side, or it's present this side. So These are all terms that are so when you give directions to somebody on the phone, you say that you travel 2 kilometers, you will see on this side you will see a shop, so then you should go on that side and there is our house. And then the people will be thinking, what are you talking about? Then you say, no, perpendicular to the place where you're standing you'll see a shop, and then you turn left for 500 meters, and on your left side the third building is our house, and then there's no confusion. Okay, so that is why we are trying to give them names based on where they are situated, and we say that the side which is present opposite to our angle is the opposite side, the side which is present adjacent to our angle is the adjacent side, and the longest side is anyway going to be the hypotenuse. Remember, if our angle is this angle here, if we decided to name the sides based on this angle, if let's say this is our angle, the hypotenuse would remain the same. Okay, the hypotenuse would remain the same. However, this would then become the adjacent side, and this would become the opposite side if this is your angle, because then for this angle the opposite side is this one and the adjacent side is this one. But for this angle the opposite side is this one and the adjacent side is this one. Are you able to follow what I'm saying? If anybody is finding this extremely challenging, please turn on your microphone and tell me something. If you're not understanding what I just said. Is there any confusion? Very good. Is my microphone off? Okay, all good. Where is it? Okay, so that's it. So now again, let's try to label all the ratios. Let's insert. So what did we do here? We did a by b, b by c, a by c, b by a, c by b, c by a, which are kind of confusing. So let us try to give them better names. So it will be hypotenuse. Say opposite divided by hypotenuse is one possible ratio. Okay, opposite side and hypotenuse side. Then you can have adjacent divided by hypotenuse. Then you can have opposite divided by adjacent. Is that right? So now we have our three ratios. Can somebody tell me why did I do this? Okay, can somebody tell me how to get the other three? Reverse them. Very good. So then I get hypotenuse divided by opposite, hypotenuse divided by adjacent, and adjacent divided by opposite. Okay, now these are very long words and these are long terminologies. There are 6 of them, so it becomes difficult to say them all the time. If somebody asks you which ratio are you talking about, I'm saying I'm talking about hypotenuse by opposite, and then the person has to spend 10 seconds to think what you're talking about. Now somebody is saying that you can use hy for hypotenuse and opp for opposite and adj for adjacent. Well, that still is not that simple because there's this by and then you have to remember the order. So there's a simple words. There are 6 different trigonometric ratios, 6 different 3-letter words. Okay, actually not 3-letter words, one of them is 5-letter, but 6 different short words or ratios that are used to name the above fractions. Very simple words. So you don't have to remember this today, but I'll just tell you this ratio opposite by hypotenuse is called sine. This ratio adjacent by hypotenuse is called cos. This ratio opposite by adjacent is called tan. And now hypotenuse by opposite is called cosec. Hypotenuse by adjacent is called secant, and the short form is sec. And adjacent by opposite is called cot. Okay, these are the name of the ratios. Now this angle, this angle here is called angle theta. Angle theta. The word is pronounced like this, and this is actually a Greek letter. This is a Greek letter, and you don't have to you don't have to worry about it at all. It is like in algebra we use x for an angle which we do not know. Here we use the terminology theta to talk about an angle which we do not know about. So when you talk about an angle, we say, okay, sine theta, cos theta, tan theta. That refers to the fact that this is the angle theta. So sine theta will be opposite by hypotenuse. Let's take a short pause at this point of time and try to understand what is actually happening. So there is a triangle with one particular angle over here, which is called angle theta. Okay, angle x or angle y, whatever you want to call it. Theta is generally used, but we can call it angle x. So we are trying to understand the ratios of the sides of the triangle. Ratios, so how big one side is as compared to the other. And we are trying to do that by giving them these names so that we know which side we're talking about. So sine theta is the ratio of the opposite side to the hypotenuse side. Okay, theta could be anything. If this is your theta, then opposite side is this, hypotenuse side is this. If this is your theta, then opposite side is this, hypotenuse side is this. Cos theta is adjacent side by the hypotenuse side. Tan theta is opposite side by the adjacent side, and then cosec, sec, and cot are the reverse of sine, cos, and tan. You call it a reciprocal, but we can use the word reverse if that is more easy to understand. Okay, so now let me pick a triangle where there are some uh, measurements to the sides. Okay, so we'll pick this particular triangle, which is one of the most famous triangles. You usually use this when you talk about right angle triangles. And now I will tell you that my angle, the angle which I want to consider, okay, for this particular problem will be this particular angle here. Okay, this angle, the angle which is enclosed by 4 and 5. Okay, this is my angle, not this one. This is my angle. So now I want you to try and tell me in this particular triangle, if this is my angle, what will be sine, what will be cos, what will be tan, what will be cosec, what will be sec, what will be cot. I don't want anybody to type the answer, and this time I'm extremely serious. If anybody types the answer there, I will remove you from the group, because I want everybody to think. Do not type anything if you solve the answer. Do not show off if you finish doing it. Be patient. Wait for 5 to 10 minutes. I myself will give you the chance to reveal your answers and explain it to others later. But firstly, I do not want anybody to type anything until I say so. Do it in a paper and pen. Remember, this is my angle. Now you know which will be the opposite side, which will be the adjacent side, and which will be the hypotenuse. Try to understand that first. And once you are done doing that, you know the measurements of the opposite, adjacent, and the hypotenuse, and try to tell me what should be sine theta, what will be cos theta, what will be tan, cosec, secant, and cot for this particular triangle when this is my angle. Okay, you can take 5 minutes. Just write the fraction. Like for example, if you get a fraction as 5 by 3, just write 5 by 3. But tell me that sine is something. Tanmay, what did I tell you? I don't want any message at all. Just wait for 5 minutes. Somebody's microphone has been turned on. If you have any questions, you can ask the question in the group, but do not type anything else with regard to your answer, or you know did not understand what is about. This is the angle. That is very important because your answers will change if this is the angle. I want this particular one to be the angle. I wish I could have labeled it and called it angle X or angle theta, but I think you can understand that this has to be the angle of reference. Sir, are the numbers 3, 4, 5 Pythagorean triplets? Okay, so he's asking a question that is completely valid, but it's slightly different from what we are currently doing. But if you just want to know a Pythagorean triplet, so you know that in a right angle triangle, this squared plus this squared has to be this squared. So the sum of the adjacent squared plus the opposite squared should be the hypotenuse squared. Only then a right angle triangle can be constructed. That is the Pythagoras theorem. So we know that 9 plus 16 is 25. So 3, 4, 5 are considered Pythagorean triplets because they can form a right angle triangle. Very good. That's a good point. So in trigonometry, if we have a right angle triangle with integers as their um, sides, then they'll all be Pythagorean triplets for sure. We cannot have a right angle triangle where the sides are 1, 2, and 3. That's not possible. So we're in trigonometry currently will only be dealing with right angle triangles. Even though some of the rules of trigonometry can be applied to normal triangles as well, but they're highly advanced concepts. We'll not be focusing on them now. We'll only be talking about right angle triangles and these 6 ratios and what are the different things that we could do with these 6 ratios. Okay, I'll give you 2 more minutes and then we'll actually list down the answers. Actually, I'll give you the chance to uh, tell me the answers, but we'll wait for 2 minutes. Any other questions with regard to trigonometry and this particular problem? Are you going to ask me a doubt or will you be revealing the answer? If you're revealing the answer, then you cannot speak. If you're going to ask a doubt, then you can speak. Yeah, so what did I tell you? I don't understand, man. You guys are supposed to be 12, 13, 14 years old. I have to repeat the same thing. If I do not tell you to type or talk, it means that you should not type or talk because we are in a virtual environment. If you type something, everybody can see it. You're not messaging me personally. Please try to understand that there are people who are trying to solve this problem and it will distract them if they keep hearing the notification sound and if they see questions and answers which are not related to this. Okay, now I want somebody to start revealing the answer. Okay, let's start with Aryan. Aryan, can you turn on your microphone and tell me the value for sine and cos? Only sine and cos.
Yes, sir.
Tell me.
Sine will be 3 divided by 5
Very good.
and cos will be 4 divided by 5.
Very good. Okay. Now next is Tanmay. Tanmay, can you tell me for tan and cosecant?
Sir, for tan it is 3 divided by 4, and
Extremely
for
good.
cosec it is 5 divided by 3.
Very good. Okay, next is Lavnish. Lavnish, can you tell me secant and cot?
Sir, sec is 5 by 4 and cot is 4 by 3.
Very good. Okay, so the others who did not get a chance to speak, Tanvi and Parv and Vishwam and all of you guys, did you do you have any confusion with regard to what they said? If you have any doubt, you can type there. If not, you don't have to. Very good. Okay. So Parv asked a question: can we write the reverse of sine cos tan as sine inverse cos inverse tan inverse? No, you cannot. You can write it as 1 by sine, or you can write it as 1 by cos, or you can write it as 1 by tan. But if you say sine inverse, that will be different. That is a completely different concept which we will not be focusing at all at this point of time. So do not confuse. So when I say inverse, that is why I did not want to use the word inverse or reverse. The better word to use is reciprocal. You can call cosec as 1 by sine, or you can call sec as 1 by cos, or you can call cot as 1 by tan, but it is not tan inverse. Okay, do not get confused by it. Okay, we will do one small thing before we leave. So I will give you a problem. This is a word problem. I don't know if you'll find this difficult or easy. So if I tell you that cos, if I tell you that sine 30 is 0.5, pay very close attention to this problem. Okay, very close attention. I don't want any messages at all until I'm done with this problem. If I tell you that sine 30 is 0.5 and if the hypotenuse of the triangle is 20, can you tell me what is the length of the side which is opposite to the angle? 30. So let me first explain what is happening in this problem. We have a triangle. Okay, we have a triangle. I'm not going to draw a diagram here, or I'm not going to send you any picture because I want you to understand the problem without looking at the picture. You can draw if you want. So there is a triangle, okay, in which one angle is 30 degrees. Okay, that is the angle theta or whatever that is you want to consider. Sine 30 is 0.5. That is the information that I'm giving you. It is half. Okay. And if you know that the hypotenuse of the triangle is 20, can you tell me what is the length of the side which is opposite to the angle 30? Do not confuse this 20 and this 30. This 20 is the length of the hypotenuse. This 30 is 30 degrees. No typing at all, please. Only doubts. No typing the answer, no typing done or anything like that. If you have a doubt, you can ask me. There is something extremely important about trigonometry and all these ratios that I have not yet told you, but I want to tell you that through this problem. That is the reason why trigonometry works all the time and why it is so important. Sine 30 means sine into 30. No, 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 no. Sine 30 means if this angle is 30 degrees, this angle is 30 degrees, okay, if this angle is 30 degrees, sine 30 will be 1 by 2 or 0.5 is what I am giving you as the information. You know what sine is. You should know what ratio sine is talking about. So I'm telling you that in this triangle, the angle is 30 degrees. That really doesn't matter actually. You don't have to actually understand about the angle, but I'm just telling you that the angle is 30 degrees. I'm telling you that the ratio of the sine ratio for that particular angle is 0.5. You should first think what is sine ratio, and then you should try to understand how that is applicable in this problem. The hypotenuse of the triangle is 20 centimeters. Then what will be the length of the side which is opposite to the angle? What did I tell you, Parv? Parv, this is the third time today that you are. I understand that is a doubt that you are asking, but can you wait for a couple of minutes? I want everybody to think that. Your doubt is perfectly okay. It's a genuine doubt, but the reason why I don't want you to type anything now is because people might not think if you already give them a hint. Okay, let's try to understand this problem. Parv's doubt is quite valid. He says, does that mean that x by 20 is 0.5 and x is the opposite side? So sine ratio is opposite by hypotenuse. That is the ratio. In this particular triangle, if this was the angle, the sine ratio was 3 by 5. Okay, but in the triangle, in the problem, the sine ratio is 0.5. So the angle is 30 degrees and the ratio is 0.5. So if sine of 30 is 0.5, it means when this angle is 30 degrees, opposite by hypotenuse will be 0.5. So if the hypotenuse is 20, the opposite will be half of 20, which is 10 centimeters. Why will it be 10? Because then this ratio will be 0.5, because sine ratio is opposite by hypotenuse. You know that hypotenuse is already 20, so the opposite has to be 10. Okay, okay, just type yes if you understood what we did in this problem. Very good, Tanvi. Very good, all of you. Very good, Parv. So do not get confused by this sine 30 representation. This sine 30 means that in an angle, in a triangle where our angle of consideration is 30 degrees, the sine ratio will be 0.5. So that is how you tell. If I say sine 45, then I mean that if this angle is 45 degrees, then opposite by adjacent will be something. If I say sine 60 degrees, then I mean that if this angle is 60 degrees, then opposite by adjacent will be something. Okay, that is why that sine theta, that's why I say sine theta cos theta, because you refer that ratio with respect to some angle. So before we finish, there's something extremely important here. I told you that sine 30 is 0.5, which means that if there is a triangle like this, and if this angle is 30 degrees, in our triangle, we had 20 as the hypotenuse and we had 10 as the opposite. Well, the unbelievable thing is, if you have a triangle where the angle of consideration is 30 degrees, however big the triangle is, whatever be its dimensions, you will still have sine 30 as 0.5, which means in any triangle in the world, if it's a right angle triangle obviously, and this angle is 30 degrees, the ratio of opposite to the hypotenuse will always be 1 by 2. If this is 10, this will be 20. If this is 50, this will be 100. If this is 1, this will be 2. In any triangle, if this angle is 30 degrees. So these ratios are the same for any triangle in the world which has the same particular angle. Now, for example, this particular triangle has sine as 3 by 5 because this angle, let's say this angle, we don't know what this angle is. Let's say this angle was some 40 degrees. Okay, this angle was 40 degrees and 3 by 5. If that is actually 40 degrees, then in any triangle in the world which has 40 degrees here, this ratio will be 3 by 5. It may not be 3 and 5, but the ratio will be 3 by 5, which means if this is 6, this will be 10. If this is 300, this will be 500. If this is 3 crore, this will be 5 crore. Because when you talk about right angle triangles, you know that one angle has to be 90, and now you are saying that the other angle has to be 30 or 45 or whatever. Then you are obviously saying that the third angle will also be same, because the sum of the angles has to be 180 degrees. So if two angles in a right angle triangle are the same, then the third angle is automatically going to be the same, which means the two triangles will be similar. And two similar triangles means all their sides, the ratio of their sides will be the same. So the sine, the cos, all those ratios will remain the same. Do you know the difference between congruent triangles and similar triangles? Congruent triangle means two triangles who look exactly the same. Similar triangles means they look the same, but their sizes can be different. So let's say a football might be similar to a table tennis ball because both of them are spheres, but they are not exactly the same because the size is different. But still, the ratio of the radius to the perimeter to the the surface area, the ratios will always remain the same because both of them are spheres. So the same way, 30 degrees, the sine is 0.5 in any triangle in the world. You can try to draw a triangle of 30 degrees. This is your experimental homework problem. Try to draw a triangle where one angle is 30 degrees. So automatically you will notice that the ratio of the opposite side to the hypotenuse side will always be 0.5, however small or big the triangle is. This you can try. Okay, thank you so much for your patience. I will wait for whatever Vishwam is typing, and then we can end the class. What exactly is Vishwam typing? Nothing? Okay. I hope you understood what we were talking about today. I know it's slightly complicated, but we will be doing this again in the next class. We'll be, continuing from where we left. So you will get more clarity. You can try to Google trigonometry. You can try to Google right angle triangle, and you can try to look at these properties and understand what's happening. Okay. Take care. Bye bye. Nice talking to all of you. Bye. Take care.